We call it the cloud. It sounds light, invisible, floating somewhere above us. But the reality is that the internet is heavy. It lives down into the dark, in endlessly long corridors packed with millions of pounds of steel, silicon, and spinning fans. When you scroll a web page or send an email, a standard computer processor handles the work, sipping a tiny fraction of electricity. But when you ask an AI model to generate a video or process large datasets, it requires clusters of specialized GPUs. Those chips draw enormous amounts of power, often 10 to 20 times more electricity than traditional servers. You can't just plug these machines into a standard wall outlet. AI servers require high-density power grids to deliver a massive, constant electrical current. And because all that electricity immediately turns into heat, these facilities have to be engineered with extreme thermal cooling systems just to keep the hardware from melting down. This exact requirement is creating a major bottleneck. Around the world, major technology hubs are simply running out of the physical real estate and the electrical grid capacity needed to support these advanced systems. We have reached a point where the speed of the AI revolution is no longer determined entirely by software engineers writing code. It is gated by raw physical real estate and electrical power. Take the Delhi National Capital Region in India. It is a dense, rapidly growing hub of enterprises and AI startups. They all require localized, heavy-duty computing power to train their models and run their applications without lag. This map shows the Delhi-NCR region. Over the last several months, Webyne Data Centre has established exactly what these local companies need: 10 megawatts of new data center capacity deployed directly across this zone. Webyne is dedicating this footprint to specialized GPU clouds and bare metal servers, hardware specifically engineered for the high-intensity processing required by AI training and enterprise cloud storage. Webyne has deployed this capacity across Tier 3 facilities. In data center classification, Tier 3 means the infrastructure has multiple redundant paths for power and cooling. If one system needs maintenance, a backup seamlessly takes over, guaranteeing 99.98%. Webyne uses a hybrid model for rapid deployment. They own 1 megawatt of core infrastructure directly, while 9 megawatts are delivered through distributed partner facilities. By plugging into pre-existing Tier 3 data centers, Webyne bypasses multi-year construction delays, deploying hardware to market immediately. While that distributed network handles current demand, they are actively building out their own footprint. Additional directly owned infrastructure is already under construction and scheduled to become fully operational within the next 6 to 8 months. Software iterates in weeks. Concrete takes years. This hybrid approach is how a physical infrastructure provider manages to keep pace with the breakneck speed of modern software development. Even with 10 megawatts online, the demand curve for computing power is so steep that this current deployment is effectively just a starting line. Over the next 12 months, Webyne's goal is to scale their data center capacity from 10 up to 100 megawatts. This 1,000% increase equates to thousands of additional enterprise workloads, supporting a massive surge in simultaneous AI training. Executing a physical expansion of this magnitude, combining owned infrastructure with strategic Tier 3 partnerships, firmly cements Webyne's position as a primary cloud provider in the Indian market. We tend to credit the future to the engineers writing the algorithms, but the real architects of the next decade of technology are the companies successfully laying its physical megawatt-scale foundations.